So we're going to go into calculating the variance of something. The very first thing we need to do is calculate the mean of all this data here. They're usually represented by something like this. Have you ever seen that in your book before? Okay, so in other words, this is our mean. So calculating mean, we know how to do that. We're just going to add all of the terms together and divide by the number that there are. So there's 1, 2, 4, 5, 6, 7 terms. So we're going to divide by 7 in this case. Great. So let's add these all together. 5 plus 6 plus 2 plus 8. I'm not going to add negative 3. I'm just going to subtract. Minus 3 minus 7 plus 1 equals. Oh, that worked out great. 12. So 12 is our total sum. So that's the sum of these is 12. And we need to divide by 7. 12 divided by 7. 1.71, let's say. It's usually nicer when we have an even number, but it's fine. 1.71. So in other words, the mean to this is 1.71 in this case. And the reason the mean is kind of in the middle there, if we were to organize that, you'd see that these negatives pull the actual mean down. So now that we have that, we then take the mean and we subtract by all of the original x values. Okay? So we set this up like a table. 1.71, and we just kind of repeat this all the way down. And we subtract by each value. So in the first case, 5, then 6. And we can do it in order, but it's fine. 2, then 8, and we subtract by negative 3. Okay, by negative 7. And what was the last value? And then we subtract by 1. Okay, so when we go through that, these are going to be our, they have a specific term for them. Deviations, that's right. These are all the deviations from the mean. Now, obviously, none of them are exactly on. We then take those deviations. So I guess we should calculate them. Okay, 1.71 minus 5. You want to help me out as we go through these?
Yeah, sure.
Okay, negative 3.29. I'll do the second one, and then you get maybe the third one ready. 1.71 subtract 6. That's easy. It's just 4 point. Okay, what would the next one be?
0.29.
0.28?
29.
29? Okay.
6.29.
6.29. Should they not be negative? Yeah, they should be, because again, this value is 1.71. So they should be negative. Not that that's going to matter in the end, but it's fine. 1 point. What will this one be?
4.7.
Yeah, this will be positive. 4.71. Okay. This will be positive 2.
8.71.
0.71. And then?
So 0.71.
Okay. Now what they do with all of these deviations is they square them all. So we square all of these deviations. Okay. And we figure out what their squares are. So we're going to have to do that next. So let's help me out with that. They'll all be positive.
10.82.
10.82.
18.4.
18.4.
0.08. 39.56.
6.
22.18.
22.18.
75.69.
75.69. Finally.
0.50.
Okay. So these are all the deviations squared. Okay. I can't remember the symbol they use for deviation. It might be this, and then this might be the deviation squared. But no, I think that's the variance in the end. Anyways, these are all the deviations squared. To find the variance, A-N-C-E, right? Variance, we add all of these terms up together.
Okay.
So when we add all of these terms up together, and then we divide by the total number of terms. And in this case, it's
7.
by 7. So we're going to add all of those up. And you think your calculator is faster than mine, so I'm going to let you do that.
$23.89.
Is that the variance, or is that all of them
That's
added
the
together?
variance.
Oh, that's it. So you already divided by 7.
Yeah.
Okay. So you divided by 7, and you got, say it again?
23.89.
23.89. Okay? So this is our variance in the end. So that's how we calculate the variance of something. Okay? It's a longer process, but it's pretty straightforward once you get the hang of it. Okay, so we found the variance. And now what I'm going to do is I'm going to add to it. I know we just said we were going to work with variance. We're going to square root this value. When you square root this value, it finds the standard deviation. Okay? So we take the root of 23.89, and what did you say it was? 4.88. 4.88? Okay, great. So that's our standard deviation. Well, let's try to make sense of this in terms of our normal bell curves. Our mean, okay, and they usually represent it in these cases, I think, with that little u, okay? But our mean in this case is 1.71, right? One standard deviation is 4.88 to the right, or negative 4.88 to the left, in other words. So a standard deviation in this case is 1.71 plus 4.88. So 6.59. So we'll just say it's here, 6.59. And to the left, standard deviation, 1.71 minus 4.88, 3.17. Okay. 3.17. Well, what we learned is how much of the data is within one standard deviation of the mean. Do you remember?
No.
You remember this? No? Okay, well, remember...
I remember doing it. I just can't remember the percentage.
Okay, so there's 68% of the data in that.
Okay.
Okay. So, and then if we were to go 2 standard deviations, okay, so in other words, we take that value and add by 2.88, or you do this and you take this value multiplied by 2 and add it to the original mean. Either way, it's the same idea, what we're doing. Our second standard deviation, and we're going to figure those out too, because this puts us into the 95th percentile. We'll do the left one first, since we already have this value up. Minus 4.88, negative 8.05. And the other one, oopsie, is 6.59 plus 4.88, 11.47. Great. 11.47. Okay. Now, within 2 standard deviations of the data, so from here all the way to here is actually 95% of the data. Okay. Now, technically, the addition, I think, when you add up just this part to the original 68, this little part's 34. But just think of it like 95% of all data falls between these two numbers. Yeah. So let's think of our actual values and see if that's relatively close. A couple of the numbers we got were 5, 6, 2, and 8. So let's start with those. Well, the number 5 falls maybe here. 5. 6 falls here. 2 falls over here. And 8 probably falls here. Okay. Then we had negative 3, negative 7, and 1. Okay. Well, 1 falls over here. Negative 3 falls over here. And negative 7 falls over here. Okay. So if you look, there's 1, 2, 3, 4, 5 of the 7 fell between the first standard deviation here. Okay. As a percentile. Now, the more we do this, closer we get to 68%. Just to see what that is as a percentage of the data. 5 divided by 7, maybe a little higher. Yeah, 71. But it's relatively close to 68% of the data. Right? Or 71, so, you know, close to 68. And then there was only 2 other ones outside of that, within 2 standard deviations. And essentially that was, well, all 7 of 7. So 100% happened to fall within 2 standard deviations. So nothing was outside of that, which makes sense. We made the estimate that 95% of the data would fall between those. So that's kind of the link between how to take mean, variance, standard deviation, and bring it to a normal bell curve. That's the whole idea. We find the mean, and then we calculate standard deviation. So you could get some extreme outliers, but the percentage of them possibly happening is
slim.
Very slim. That's right. Okay. So that's how we kind of connect everything together. So that's going through variance and standard deviations.